We're looking at three charges, all suspended by very light strings, all lined up in a row here, so that the length of this string equals the length of this string. This one's a little bit shorter, so that all of these are in line with each other. They all have the same Q, and this one is being repelled outwards, this one's being repelled outwards, and this one, of course, is held in the middle because it's being repelled in both directions. Same mass for the balls for each of these charges, and same angle on either side. Our job is to find out the magnitude of the charge Q. Now let's draw forces on this charge here and apply the superposition principle. This charge is affected by this charge here and this charge here. So forces on this straight down would be force gravity, and we would be upwards this way and this way. This is force tension Y, and this is force tension X. I try to draw that so that they are about equal. Let's label those. This is force gravity straight downwards. Here's our force tension going this way. Therefore, this is force tension Y, and this is force tension X. Angle theta is right here. So this is our force tension going this way. Now, force gravity and force tension Y are equal to each other. So, of course, force gravity is mg, and force tension Y is mg. Okay, now this force tension X here is also the force tension X pointing this way. Think parallelogram here. So this is force tension X. Now what's opposing this direction here is going to be the force electric caused by this charge and this charge. So again, we will be applying the superposition principle. But force electric going in this direction must equal force tension X and going in this direction if there's nothing moving. So that's our analysis so far. Let's kind of get some equations here to help us out. So our angle located here, we could apply tangent of theta equals opposite over adjacent. So I'm going to say tangent of theta is equal to force tension X divided by force tension Y, but force tension Y is mg. So force tension X is equal to mg tangent theta. Okay, now what is that equal to? Let me choose a different color so it doesn't get too confusing here. Okay, so I'm going to choose red. Okay, so this charge here is causing a force electric here, and this charge here is causing a force electric. Okay, so we have a force electric acting on this, but really we have a force electric 1 and then a force electric 2 that comprises that force electric. So maybe this force electric is caused by the repulsion from this charge, and this force electric is caused by the repulsion of this charge. Both add up to be the total force electric acting opposing the force tension X. So let's write an expression for that. Okay, so force tension X is equal to force electric 1 plus force electric 2. And that's applying our superposition principle. Okay, well, we're going to be using Coulomb's law. Force electric equals K. And this time I'm going to kind of cheat. I'm going to say Q squared divided by R squared. Why am I doing that? Well, they're all the same charge. So it would be Q1 times Q2. Okay, so that's Q squared, all divided by R squared. Now the only difference now is I've got a radius here, a distance from here to there, and I have a radius from here to there for this charge here. Okay? So I will draw this in red. The distance from here to there we can call as radius 1 maybe. And then from here all the way to there, I'll just maybe do some dashed lines here. We can call that radius 2. Well, it's based on this right here. So L sine theta is going to be here. And from here to there is twice that. So our equation is going to be like this. mg tangent of theta is equal to k q squared over L sine theta, and I'm going to square that, plus k q squared over 2L sine theta squared. This expression is completely known. Down here you will know those. The only unknown in this is q, and then you can find q, which is the goal of this question, finding the charge, okay, on all three charges. Now, since they're all the same, again, we're just using q for that. And that's how you will solve this using three charges. So it involves, tension in the y, tension x, a system that we've seen before, and the superposition principle. Because why? We're looking at the force between these two and adding it to the force between these two.